Next, we're going to move on to the irreversible reactions of ketones and aldehydes. And the first reaction we're going to talk about here is a reduction. In the reduction of ketones and aldehydes, we can use both our strong and weak reducing agents that we previously talked about in our discussion of carboxylic acids and carboxylic acid derivatives. So if I have an aldehyde like this one, I can treat this aldehyde with sodium borohydride, followed by an acid workup, and the product that I would get out of that reaction is a primary alcohol. I have two hydrogens at that original carbon of my carbonyl, so that this is the carbon of my carbonyl. This is that same carbon in my product. My product is a primary alcohol, and I made that primary alcohol from my aldehyde starting material. Remember that sodium borohydride is one of my weak reducing agents, and I can use that weak reducing agent because my aldehydes are one of my more reactive functional groups. It's always better to use the weaker reducing agent if your molecule will still react. Sodium borohydride is a safer reducing agent than what we see for lithium aluminum hydride. The mechanism for this reaction would be the same. We have our borohydride ion, which is a source of H-, and it can transfer one of the hydrogens with its electrons to that carbon of the carbonyl, send the electrons up to the oxygen, and that's going to give me a tetrahedral intermediate that looks like this. This tetrahedral intermediate can't collapse. This tetrahedral intermediate doesn't have any leaving groups. And so this is what I have at the end of step 1. Once this intermediate forms, it's stuck. It's not until I add that acid workup that I can pick up my proton and make my final product, which is that primary alcohol. If I have this same aldehyde, I can also treat this aldehyde with lithium aluminum hydride, followed by an acid workup. This is a workup up here, followed by an acid workup, and I'll make that same primary alcohol out of the reaction. Remember that lithium aluminum hydride was my strong reducing agent. So that means that we'll reduce my most reactive and my least reactive functional groups. So both reagents will reduce the aldehyde in this case, but sodium borohydride is going to be a little bit safer, but lithium aluminum hydride will work as well. If I have a ketone like this one here, I can treat this ketone with sodium borohydride, my weaker reducing agent, followed by an acid workup, and the product that I get out of that reaction is a secondary alcohol. So my ketone allows me to make a secondary alcohol through its reduction. I can accomplish this same reduction using lithium aluminum hydride, followed by an acid workup.